I know you have. Oh,
Bro, we have a whole from 9 p.m. to something a.m. You're going at it. Starting some fun.
Yep.
And what was happening?
I can't say.
Well, let's just say
So we were doing some DIY drywalling.
let's say the Brady's a very good stable receiver.
I got the recording going.
Oh, allegedly.
Most of the class hasn't heard that story. That's a come to chapel story.
I do not think
It's a lunch table story. Okay, so let's get rolling. What I'm going to do is I'm going to cover the stuff from last class. I actually want to talk about a couple of things because this is I think a good example of use. Oh, by the way, I moved my my thing up here to the top so I don't have to look for it as much anymore. See, wasn't that smart? Yeah, I know. It's so good. All right, so if we look at, so here's kind of a good use of AI stuff. So I want to kind of give you guys like a little bit of a forward thinking thing, but it also led to what we had to do last time. All right, so how many of you have used AI at all to do any coding? Yeah. I mean, and the hope is that if you're doing it when you're working on your homework or something like that, it's you get stuck, you put something in, you let AI generate it, then you walk through it and figure out what the heck is this thing doing. And then hopefully between what you tried to do and what it did, you're able to figure out the truth in the middle, right? Okay, so and this is kind of a cool use of AI on top of this. So we have this situation where we need a JSON parser. We're working in a programming language that supports JSON, but in kind of a janky way. And since we're in a string-based language, we might want to create something that says, hey, I want you to take in a JSON string and give me the result in a way that I can process it. You can give it some information about the specific thing, and it'll generate that parser for you. And something like this is actually probably a pretty accurate way of doing things. Like you probably can rely on it giving you an accurate JSON parser. We'll see if this makes me a lie in the end. But that's where this JSON parser came from. It was just ChatGPT, create me a JSON parser. I'll usually be very targeted with prompts. I'll say, I want it all inside of a single class. That way you don't get this whole library of 10 files that you have to run and stuff, because really, we don't have any intention of changing this tool. Right? We ran to Home Depot. You know, we already have our mind wrapped around kind of the concept of JSON. We know there's parsers already out there. We started writing our own parser. We saw that, hey, if we throw enough hours at this, we would eventually get it right. But hey, these things already exist. Or I have this generative AI. I can just ask for it in the right way, and it'll give me the exact tool that I want. Just as if I walked into Home Depot and walked out with a chainsaw or something like that, that does the job it was intended. But then what we had to do is we had to go and, well, first of all, notice that inside the documentation, inside this thing, it tells us how to use it. But I'm actually going to walk through that a little bit. Because actually I mostly agree with that. But what we started doing last class is we were going through the JSON parser and looking at each level and asking it, we said, get class name, I think was what was called. And that's going to tell us, because we're getting everything as these generic objects. So a generic object can hold any kind of thing, right? We can put anything that is an object inside of a generic object. Now, that thing we threw in there is what it used to be. So if it was an instance of the map object, it's still an instance of a map object, but it's wearing a generic object costume. You can think of it like that. So he doesn't identify himself as that. If we look inside the container and we see this thing down there, it's going to be advertising itself as a generic object. Now, all objects have a get class name function. And some objects can choose to overwrite that. In fact, actually, modernly, that actually might get overwritten for classes by default, and just pulls the class name. But that allows us to say, hey, generic object, what are you really? Tell me your actual class name so that I can work with you with your specifics, not your generics. Because if I pull this thing out and as far as we know, it's a generic object, all we're allowed to call on this guy is things that are part of the documentation for generic objects. So even though this guy might be capable of doing more, that doesn't necessarily mean that well, just because he's capable of doing more, Java's not going to let us call more stuff on him until we clarify what kind of thing it is. So we would have to tell Java what this guy actually is in order to work with it that way. And then we'd have the full selection of methods. So if we go to driver here, and let me just want to make sure that I'm sharing and everything. Yep, it looks like it. All right. So here's driver. Here is us reading in our data file. So that's our very first line there, line 36. That's us taking in our cruise ships.json data that we read above. All right. But we're storing this guy as a generic object. All right. Now, let's see. I want to do just for a moment, I'm going to comment these out. And what I'm going to do here is I'm going to do a system.out.println obj dot get class name. Is that it? I think that's the name of the function. Otherwise, we'll go look it up real quick. It's not. Java object. Get class. All right. So right off the bat, we are seeing it as an object. What it actually is under the hood is something called a linked hash map. And this is actually important because this tells us, remember looking at the documentation over here that they gave us for how to use this dude, said use it this way, treat it as a map. So now real quickly, I'm going to just show you linked hash map Java. And we're going to see that in the, let's see, linked hash map is a hash map, is an abstract map. All these guys implement an interface called map, which means every single one of these guys plays by the rules of a generic map, whatever map says it can do. So if we look at map real quick, and we go down and we look at the things that you must implement to implement the interface called map. So remember, map is not the name of a class. Map is an interface, which says any class that claims to implement this interface must have the stuff I've described in this documentation. So we can rely on those functions being there. Now, these are things that are already written into the language, so we don't actually care how they're implemented. We might be interested in that, but doesn't matter as long as the tool works. You come home with a chainsaw, you don't rip apart the engine and see what unique thing they've done with this chainsaw. You start it up, you realize, okay, I got trees to cut. You go out and start cutting stuff. Maybe later on when it breaks, 10 years down the road, you might crack it open, with that dream that you're going to be able to fix it. And realize that your hands are way too big to fit into any of those small spots. Then you try to hire a freshman to come and do something with it, and then you end up just buying something new anyways. This sounds like you're coming at this from experience. All right, so if we look at map and we just want to see here's the things that we can do with map, we can tell a map to clear itself, remove all the crap. I'm only going to hit the highlight reel. We can find out all the things that are inside of it with a set. Let's see. There's a built-in kind of for each that allows us to go through it. We can get an individual value given a key. What is that sounding like to you? If I say, hey, give me the value associated with name, what does that sound like to you? From a dictionary. So from Carnival's favorite language, Python, and Python did not invent dictionaries, by the way. Yeah, that's okay. We only steal the best.
Python stuff.
Well, look, I have a whole directory here. So I have a whole directory here with like all my active projects. Shut up. Shut up. So I have a whole directory here with all my active projects that I'm working on. I would bet 90% of them are written in Python. So, Python is a good language. Python is just a language that you're training to be able to take advantage of because Python is effectively like that power tool. It just has so much stuff built into it that takes away the learning experience for learning how to do the stuff under the hood, that it's just a poor first language. Okay, so in any case, we can add something. We can add a key value pair, still sounding like a dictionary. We can remove stuff from it, blah, blah, blah. We can get a collection of its values. So this looks like it just gives us the values of it, not the keys. Now, what's interesting here, though, and this is something where I think the documentation they showed us is maybe a little bit misleading. And since Carnival is so excited about Python, are you able to tell us any maybe nuanced information that we probably should know about dictionaries? So we know dictionaries are name value pairs, right? All right, and can we just iterate through a dictionary and rely on the order in which things are going to come up? Yeah, so by definition, for some reasons, I don't want to go dive down that hole, but by definition, a dictionary does not guarantee order. That's usually, actually, that's something I can't think of a language where that's not a true statement. Now, you might be able to, maybe you look at Python and you see that, okay, yeah, they follow a consistent order based on how I put things in there. So maybe you can kind of figure out Python's implementation of dictionary and decide whether, if you can predict the order. You might be able to. I don't know if I've ever checked. But in any case, it does not guarantee order, which means the way you're supposed to interact with a dictionary is say, hey, give me the value for this key. Just figure it out. I'm not going to go and search through you looking for it in all the little nooks and crannies. That's the dictionary's job. I'll tell you what I want. You'll give me the value somehow. But operating off this idea that there isn't a guaranteed order tells us a little bit about how dictionaries are typically built. And it also shows us something that is hidden from us here. So when they say treat this guy as a map, he's saying treat this guy as some class that implements map. And we just saw from the map interface here, if we go up to the top, that we have a bunch of classes here that implement map. So here's a bunch of classes inside of Java that all have every one of the functions that map has. They might also implement some other interfaces. They might have some additional stuff. They might also implement their own extra stuff over and above what map gives. But at the very least, they have every single thing that map knows how to do. All right. So these different things tell us information about things that act as maps. So the documentation we got here says, oh yeah, just treat it as something that is a map. of string followed by object. So remind me, what is that called when we have something in like those little angle brackets there? I think we talked about it last semester at some point. Okay. Well, it's called generics. Does that ring a bell? Okay. Well, so now is a good enough time as any. I don't think you remember much. Sometimes you're coming in with a pretty decent haze. You're still drunk from last week. All right. So let me add that real quick to the notes here. Just the idea of generics. I really remember talking about it, but whatever. So generics, this allows a programming language to create general classes that can work on general data, we can say typically object types, yet are designed to be, call it enlightened, as to what kinds of data it is actually holding in a specific case. So here, I'll use our example from here. Take this guy. So in this case, map is a generic interface which works on name value pairs. And in this case, we have specified, missed it. Perfect. Specified that names are strings and values will be objects. Now, why didn't we make values strings? Remember, our job here is we're parsing JSON, right? Well, the whole JSON document we have is a giant string. But when we get to a JSON object, you know, the curly braces with a whole bunch of comma delimited name value pairs, those guys, so kind of, it sounds like a dictionary. Heck, it's even written with the syntax of a dictionary, right? What kinds of values do we find within a JSON document, or we find inside of a dictionary if you want to think about your experience from other languages? Do we sometimes find strings as the value? Like if we had a the name, if we say the name is name or first name, the value might be the string Mike, right? What if we have the string age? What kind of value is the what kind of type is the value? Probably an int. I mean, could be a string, but it would make sense for that to be an int. So JSON can also hold integer types. Huh?
It could be a short.
Could be a short. I think JSON only supports generic integer types, but I mean, you're not wrong. Could be a byte, could be very small integers, you're right. Well, what else? What other kinds of things might the value be? What about a floating point number? Could that be reasonable? If we had a name called pi, the value would probably be 3.14, blah, blah, blah. So we need maybe floating point numbers, could be potential values. Anything else you could think of as a potential value, specifically in our JSON? The top of our JSON, we have a single name called ships. I'll take you back to our JSON here. So we have a name called ships. And what kind of value is this guy? A collection, an array, a list, you know, a collection of stuff, right? So right off the bat, we've named several different types that can be that value, right? So if we go back to this guy right here, we are saying, now, if all of our types were integers, we wouldn't say object here. We would say integer. If all of our types were strings, I'm sorry, if all of our values were integers or all of our values were strings, we would say string here. But in our particular case, we support a couple of different types of values. Therefore, in order to support various types of values, we're going to say our value type is object, and we will then cast it to the right kind of thing when we go to use it. All right. But that's why we are choosing to use, this is our generics here. We are saying, hey, this is a map. We know maps are name, value pairs. So two things. So we're saying this specific map has a name of type string. So every single one of the names will be string. In our example here, our names will be ship name will be a name, gross tonnage will be a name, max passengers will be a name. Every single one of them, every single time will be a string. And we are advertising it as such. But our values are more flexible. We're supporting multiple types of values. Therefore, we're just going to, I mean, there might be a world where all of our values of our instances of a certain kind of type that is more specific than object, but still fairly generic. But in our case here, we're basically saying, look, our values can be, from a Java perspective, anything under the sun. It's an object, and I'm just give it to me generically so I know I can hold it. I'll figure out what kind of animal it is later. Go ahead.
It's like basically a general guideline.
Well, sort of. So, I would say generics, it's not a general guideline, but maybe you mean it this way. It's that it's your way of taking something that was implemented in a very generic way and making it target your exact type of data. Yeah. So that way you can have this one object, this one interface, in this case, map, and just say maps were designed generically, just like we write our functions to work on different inputs, right? Map was designed to work generically. That way we only had to write a map-like thing once. Then we can provide it some runtime information to say, by the way, whenever I get a value out of this, give it to me in this case as a generic object, which is probably the default behavior of it. But whenever I ask for something, I will always give you a string for the name. Therefore, internally, when you call get on this guy, we had looked at the documentation. Let's see, does get take a string or take I just don't want to misrepresent this. Does get take a string or an object? A, B, okay, yeah. So here we see get. Notice the default behavior for get when we give it the key. Remember, we've just talked about our keys. If we look at our specific keys are the string ship name, the string gross tonnage, the string max passengers. All of our keys are strings. But notice that in the documentation, the way map was generically built, it said, okay, your keys can be anything that's an object. What we're doing is, so when we call get, it's going to expect us to give it an object, and then it's going to cast it. Well, maybe not be able to cast it, depending on what we give it. But if we know that all of our keys are strings, right here, we are saying, trust me, all my names are strings. So when you now go to use that instance of map, it will, whenever you call get, it expects you to pass it a string. And if you pass it something other than a string, it will yell. So it allows you to make it fit your problem, almost like getting a custom pair of pants. It fits exactly what you're trying to solve. Yeah.
Yeah, that's what I meant by.
Yeah. This was introduced, the concept of generics was introduced in a later version of C++, I believe. Because it's definitely in modern C++. I guess it's possible it came out in Java first. but yeah.
Never seen it last year.
Yeah. And it's because this is like a lot of programming stuff, right? You look at it and it just feels complex because it's got weird symbols and all this stuff. And you get a little, you know, huh? I guess I can't tell you the exact syntax if that's in there, but I would be shocked if it's not. Yeah. So just from strictly a language perspective, it would be very surprising if it's not. The only rationale would be that since it's already a loosely typed language, everything is kind of already not typed. But now that you've seen, some modern Python allows you to type it when you're trying to write something for speed. So Python's already tried to add some stuff in there to make it less slow compared to C++. It then binds you into some platforms, but I mean, who cares? Everybody runs their Python on Mac, PC, or Linux. Fine. Move on. All right. So generics is the syntax where we have, well, let's get that in the notes. Oh, I'm already in the notes. So we'll say syntax is that guy followed by stuff followed by that guy, where dot, 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 I have enough dots, whatever, is one or more specific data types depending on the complexity of the object we are working with. Since we're going to see this here in a second, I'm going to give you a secondary example of using generics that only uses one of them, just so you can see the difference. Because really, the double generics, like you said, you were scared of it. That's extra scary. When you only have one thing in there, it's still scary, but it's less scary. So for example, if we build an array list, which is something that exists in Java, just pretend like it's an array or a list from Python or whatever. It's a flexible array, an array that you don't have to build to a fixed size. You could add stuff to it arbitrarily, and you don't have to worry about the train wreck that's happening to your memory under the hood, because it is implemented using normal arrays. So we might say array list AR is equal to a new array list, something like that. This creates a generic array list capable of holding objects, which means it can hold anything. Now, at first, you might say, oh, that sounds convenient. If I can create a collection and it can literally hold anything. Perfect. Well, that means if you think this is good, then you will love typecasting every single value you get from this array list, because they will always come out as generic objects. They're still the real thing. They're still whatever you put in there. But as soon as you put it in there, it throws it into a generic object costume. So no longer looks like what it used to be. All right. Where generics, so if we say array list of string equals a new array list of string, now this guy always gives you a string as output and always requires a string as input, because it can only hold strings. That makes sense? And this also, I mean, you can be flexible with this. You can say, like, for instance, if you remember from last semester when we were writing our MUD, we had this idea of an inhabitant. And from inhabitant, we had a player and a monster. Well, we could have an array list that holds inhabitants, where it can hold collections of anything that is an inhabitant. So I can throw monsters and I can throw players in there at will. And then when I pull them out, it'll come out as a generic inhabitant, which, yeah, it's not quite a player, it's not quite a monster, but it's closer to that than a generic object. And then you can just ask the question, well, is the guy I just yanked out, is he an instance of, if you remember the instance of operator, is he an instance of player? If so, cast him to player and go get to work. Else, if, or for us, else, he must be a monster. Cast him to monster and work with him as a monster. All right. So generics allow our objects to work that way rather than you having to constantly convert objects to what they really are. Make some sense? All right. So that's the world of generics. Anytime you see these little angle dealios, that's what's going on with it. All right. It's a convenience. It's not actually scary, but angle brackets feel foreign in the middle of your code. Well, I already had used parentheses and other stuff. So, we're right back to the crazy Lippmann delimiter we had a couple classes ago. So square bracket or angle brackets don't seem so bad in that case. All right. So swinging around, notice here that when I looked at, and just to remind you the code that did this, I read in the object that my parser gave me. It came out as a generic object. I wanted to find out, hey, who are you really? So I asked him, because all objects have this ability, I asked him to give me his class. Okay, kind of like what's your occupation? Something like that. And at that point, he told me, oh, yeah, I'm not actually a generic object. I'm actually something called a linked hash map. All right. Now, how many of you, if you look at something called a linked hash map, feel like that's a little scary? Like, what the heck is a linked hash map? Yeah, well, it has the word map in it. All right. But what about the rest of this crap? All right. Now, the good news for us is we can always go into the documentation here and we can click on we're blah 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 blah. We can click on linked hash map here, go right to this guy. Notice we have a linked hash map, which is a hash map, which is an abstract map, which is an object, but it fulfills all, let's see, it implements the map interface. He also implements something called serializable, but I'll talk about that at another point in time. And if you go down, we know how to read documentation, right? So we can go down here and say, here's a method. It's called clear. Is it a class method or an instance method? It's an instance method. How do we know? I don't see static. How do I call an instance method? Using an instance of this class. So I must get an instance of linked hash map, whatever that is. I must get an instance of that if I want to call that function. And then you can read the little stuff next to it or whatever. You want to get an introduction to this function, you can look at the stuff up here, or you can just highlight it all, paste it into ChatGPT and just say, can you give me a summary as if I'm a 12-year-old as to what this class is used for? Up to the races. If you want more details, then upgrade to a 15-year-old. Right? Let it teach you about this stuff. But once you have enough stuff under your belt, you can make some pretty good guesses about this stuff. So if we go back here, when I see something like linked hash map, several things come to mind. First of all, we already talked about the idea of a map, right? So map says to me dictionary. All right. The linked part, we've already talked a little bit about the concept of linked lists. That's the thing coding 3 is called data structures. So we get into these linear and non-linear linked data structures. Bottom line is, think of an array that grows, but we're going to write them ourselves. That's a linked list. Our room structure from last semester was a linked list. We had a room and it pointed to a next room, right? It actually was a multiple linked list because we had a room that by the end pointed to up to 4 other rooms. right? So that actually kind of sort of became something called an n-ary tree, even though we called it a room. It actually, when you looked at the structure, it's an n-ary tree. So in coding 3, we'll talk about binary trees and n-ary trees and AVL trees, which are self-balancing trees, and all these other cool things, blah, 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 that realistically, when you get into actual industry, you'll probably be using those tools directly that are already built into the language. But understanding how they're actually built under the hood is going to help you solve some problems. It'll also help you be less scared when you see new stuff. All right, so linked tells me, okay, under the hood, this guy is likely memory efficient because he's working with a linked data structure rather than requiring contiguous memory. So that's what I hear from that. This guy is a memory efficient map type. Okay, what about this dude in the middle, hash? Skip past the first 3 things that come to mind. And what's the 4th thing when you hear the word hash as it relates to coding? So we're not talking about, hash browns or other hashes that might be coming to your mind. But when you hear hash in the computer science mentality, what is hash? Okay, what's a hashtag?
Comment.
Okay, social media thing with the pound symbol before it, so kind of it gives us a little information. Okay, that's not this hash, but that's in technology. No, that's reasonable. Yeah, it's not this hash, but at least we're in technology. Something else? Tell me what a hash is. You're on to something. Tell me about hashes. Okay. So at this point, you're kind of talking about uses of hashes. So let's talk about the idea of a, a hash. I'm going to put in parentheses next to it. It is a cybersecurity type concept, or at least is heavily used in cybersecurity. This would be called a hashing algorithm. So something that is a hash was developed using something called a hashing algorithm, which typically, which commonly gets used in cybersecurity, but existed before that. So definition of a hash is a one-way cipher. That's way more explanatory, right? So what does a one-way cipher mean anything to anyone? Yeah. So this means once you encrypt it, here I'm going to say encrypt, once we hash it, we can't go back. Now, does that sound very useful? When would you want to encrypt something but never be able to get back your original information? It's like, hey, I'm going to send you this email. It has the coordinates of the treasure. I'm going to encrypt it. There's no way for you to get back to the original data. I wish you luck and Godspeed. Right? That's not a great use unless you send that to your enemies, right? Okay. So when might a hash be helpful? Can you give me an example of when a hash is helpful? Okay. Do you know any common technologies that are used for doing exactly what you just said? How many of you have ever downloaded a large file and then it had something called an MD5 below it? We have something called MD5. This is the 5th generation of this. So this stands for Message Digest. This is a hash, is what that is. So hashes hashes have an arbitrary size input and a fixed sized output. So that means if I have a 6 gigabyte file, big file, and I have a 64-bit hash, I can take the entire contents of that file, pass it into this hashing algorithm, and 100% of the time, it's going to give me a 64-bit key, 64-bit hash that I cannot go back to the original. Once, I mean, first of all, I'm taking whatever I said, 5 gigabytes, 6 gigabytes. I'm taking a bunch of gigabytes and I'm turning it into 64 bits. Either this is the most amazing compression algorithm ever, or this is a one-way trip, right? Why would I ever want to take the 5 gigabytes and turn it into a hash? Now, if you apply the MD5 algorithm to that 5 gigabytes 100 times in a row, you will get the same hash. So it's not a random thing. You will get the same 64-bit sequence for the same 5 gigabytes every single time. So the reason you'll see that for large file downloads is you can download the file, then do an MD5 on it locally on your computer and compare the two hashes. And that will tell you whether you very likely have a clean download. Now, why do you think I said very likely rather than it guarantees you had a clean download? I have an arbitrary size input. That means I can give it any input. I can give it a single email. I can give it a terabyte. And it will give me 64-bit output. How many unique 64-bit outputs are there? A bit is a 0 or 1, right? I have 64 of those. How many unique ways can I write 64 zeros and ones? 2 to the 64th power, which is a super big number, right? But it's not infinite. So that means there, oh, go ahead. That's always the risk. Yeah, so he said, you know, could we run out of keys? The answer is sure. You know, if I take in any size input, that's literally an infinite number of different inputs from our perspective. Yet I am stuck with a collection of 2 to the 64th number of potential outputs. The number of unique outputs I can create is smaller than the inputs I can take. Therefore, there are possibilities where I can have 2 completely different documents that happen to hash to the same value. Possible. Really improbable for an individual person to just happen to have 2 pieces of data that hash to the same value. Mathematically nearly impossible, but technically can happen. Most hashing algorithms like MD5 have kind of they have various mechanisms to avoid what are called collisions, 2 things mapping to the same thing. So that's something you'll talk about like in a cybersecurity class. For us, we're more interested in just the hashing aspect of this. But effectively, every value has a hash that is associated with. So when it gets stored, the key is stored in, well, the data structure is built based on probably an array of hash values that it uses as a lookup table. So when you pass in the name, it hashes that and goes and gets the value associated with the hash. That's why you lose that process of that handoff is why you lose the guarantee of order in this thing. Now, if I were writing a dictionary, from my perspective, there's no great reason to use hashes, right? So realistically, something like this probably starts tiptoeing into a cybersecurity world where, okay, if we're sending these dictionaries around, maybe we don't want to be quite as clean with exactly the values that we're storing if we're passing this over the internet or something like that. that would be beneficial if both sides know what the keys are. And what's actually being transmitted has hashes. And it's a one-way cipher. You can't take a hash and go back to your key. Yet we know that one of our keys is ship name. So we can pass ship name through a hash and then just look for the hash that matches that because we knew what the name was. So there's a little bit of security built into our thing. You know, this isn't Fort Knox, but if we're passing this over the internet, we have some protection. You're going to see us pass something through the internet here in a second. All right. So when I see linked hash map like this, it reads to me as, this is just like a Python dictionary. It does not guarantee order. It maps name value pairs, and it's a linked based data structure, so I don't have to worry about memory. Tells a story. Now, from a user perspective, is it super, super, super important that we know the story? Maybe not. But from a computer science perspective, it might be. Because sometimes we do have to make those decisions about, hey, I am sending this over the internet. How sensitive is the data? In this case, well, certainly dealing with Pokemon or something like that, not that sensitive. But if you're doing other things, there's some decisions that need to be made, and that might lead us to pick a certain implementation of a map over another one because of a security type of concern or something like that. All right. So that's why we get linked hash map there. What does this really tell us? It tells us the kind of animal we're dealing with is a map. We don't have to care about the hash part of this for us. It's not important. It's more of trivia knowledge. We know that's how it's done. It's not impacting our lives at all. Go ahead. Because this JSON parser that was generated for us basically said, you might be sending this stuff over the internet, so I'm going to go ahead and always deal with your stuff as hashes. Yeah, built-in security. If you didn't need it, it's not hurting anything. This is probably not going to be the bottleneck of your application for very long. So who cares? But it did the work for us, so we don't really have to worry about it unless we know we really have to know about it. Passing credit cards or something like that, right? Where we know we need to take it seriously. Okay, so that's what that guy is. So we're able to kind of do an investigation into our code and find out, hey, what am I actually working with here? And generics are a way to kind of avoid that once we know what kind of animals we're dealing with here. All right, so we have a map where all the keys are strings. The values are objects because we already talked about values could be strings. It could be ints or floats. It could be an array. We have different kinds of values, so object will cover us there. We're going to name our variable there root. We're going to go ahead and say, hey, give me the object, this guy right here that was returned by our parser's parse function. Give me that object, and we are going to typecast it. So typecasting has us put in front of a variable an opening parenthesis, a closing parenthesis, and then the thing in the middle is the thing we are saying that guy should be treated as. Don't make it up. He needs to actually be that, right? if we say that this guy is actually an instance of random, and we put that in front of object, and we start trying to use random functions on object, we are going to have problems, right? So make sure you're casting it into something that it actually is, not just what you hoped it was. so maybe double check. Put a little get class on the end and make sure whatever spits out is something you can function with. All right, so we're using generics here so that root knows what we're dealing with. We're then asking root to get us the value associated with the key called ships, which is our top level value here, right? There's the key, which is ships. The value for that key looks like array stuff, right? And if you were to do the get class thing, you would see it's an array list. That's what it would print out, just like the other one said linked hash map. This guy would print out array list. So I am saying, this is an array list of maps. That's what it is. We already saw that something that looks like a name value pair is stored as a linked hash map. Therefore, a collection of name value pairs would be stored as a hash map or a map. All right. So this guy right here is an array list, a collection of maps. That's what we're dealing with, right? Okay. So that's why we're saying root.getShips, the value that that dude's given me back, because I know the nature of my my JSON will be an array of maps. That's what he's given me. So I've used generics to describe that. That way, when I go to work on it, I can just use it. So now I have my little for each loop. So I have map O, I'm just calling the variable O, out of AR. AR is a collection of maps. So for each map that I'm temporarily naming in a variable called O, I can call it whatever I want. I can call it LOL or whatever. Every single one of those I run into inside of array, I want to go ahead and print out that guy's ship name. So O.getShipName, which I'm asking the map. I'm passing ship name as a string. It's going to give me back a object. Give me the gross tonnage. Give me the max passengers. We know this is going to work out fine because these objects all have a toString, so I'll be able to see the value. If I'm dealing with gross tonnage and I want to do math with it, I will have to parse the integer out of it. But right now, we'll see that we are getting all of our data. Oh, perfect. So does that mean I lost all my stuff? Huh, copy, Ninja. Okay, looks like we're okay. All right, so there is our ship name, gross tonnage, number of passengers, yada, yada, yada. So we're good. We're good there. All right, so that's these three print statements. So that's our JSON parser that we have that's in action. All right, questions about our tool that we bought from Home Depot that we now know how to use? All right, so now let's look at a real API. So right now we are dealing with what we read in from our cruise ships.json. So for the moment, I'm going to comment out this stuff. I'm going to show you that there is this, well, I'll come to that in a second. There is this API, this lives at pokeapi.co. Pokeapi.co is where their API lives. And I'm giving you a sample thing to work with here. So if you were to take this endpoint, so here's pokeapi.co/API/v2/Pokemon. And then we have this little question mark thing. I'll talk about that here in a second. Limit equals 100,000 and offset is equal to 0. That says start at the very beginning of the list of all the Pokemon, offset 0, and give me the first 100,000. Give me all the Pokemon. is what that says. All right. So when I issue that, I get this wall of Pokemon. All right, cool. And that's all JSON-y stuff. You see that? Looks like JSON-y stuff. The very top. You know what? Actually, what's interesting, we'll have to see how it really comes in. It's possible that's poorly formed JSON. It might not have a top level thing. We might already have our collection of stuff, but let's see what we're working with. This is a pretty old API. All right. Now, when we deal with APIs, have we talked about HTTP yet? What can you tell me about HTTP? All right, Hypertext Transport Protocol. All right, so that's its name. Who cares? Whatever. What is HTTP? let me throw one thing out there for all computer science people to know. So this comes into one of the other, let's call it scary things. The word protocol feels a little scary. Protocol. How many of you saw Star Wars? C3PO. What was C3PO? What kind of droid was C3PO? Protocol droid. What did he do? He knew a zillion languages, right? So he knew a whole bunch of protocols. A protocol is a language that two things speak to each other. We are currently using the English protocol, right? I speak English, you speak English, we can communicate using the English protocol. Well, in this case, we have a protocol that allows two things, or at least two things, to communicate with each other. Does anybody know what HTTP was originally created to let communicate with each other? The originally is a little bit loaded because probably it was done slightly before this, but for the same purpose. It would have been text-based before it was graphical. But what problem does HTTP solve?
Doesn't it kind of like determine what gets kind of transferred throughout the internet, if that makes sense? Like it's a protocol, so it must have like a set of rules of what what a website can and can't do.
Yeah, I mean, it does, just like English has a set of language. And yeah, it lets two things across the internet communicate with each other. Do you know what those things are? Okay, you said websites. Well, HTML is the data that might be sent through the communication. So we
Could
have
it be the form of the website?
Who?
Like how the website is formatted so it communicates properly? I guess it looks good, like it's not gonna mess up anything.
Okay, that would probably be the HTML. So we have something called the web browser, right? Everybody knows about their web browser. You have your favorite web browser, Chrome, Edge, Safari, Firefox. You're probably using something stupid. What are you using? Brave. I use Brave through because they have an API access to Brave. So Brave is used in a lot of agents. But in any case, Brave is probably Chromium, isn't it?
Yeah.
Yeah. So
Did you say Edge? No way.
all right. So in any case, we're throwing around a whole bunch of words there. So we have our web browser, right? Whatever your web browser is. Now, who does the web browser talk to? A web server. Okay. So we have our web browser. And this guy talks to our web server. So usually the web browser lives on our device, laptop, phone, whatever it is. We open up our web browser, we type in www.google.com, whatever, and press enter. What happens then is your web browser formulates a request in HTTP language. And it then sends that request over the internet to the web server you've described. In this case, it's www.google.com. Now, there is a little bit of an intermediary there. What happens is the google.com thing goes up to something called the DNS server. The DNS server then translates google.com to an actual unique IP address. So really, we're sending that request to give me google.com where we're sending that request to the web server at an IP address. Relatively unimportant in this. So browser talks to Google's web server. Google's web server speaks HTTP. Your browser speaks HTTP. Your browser makes a request. The server says, oh, you're asking for Google's homepage, index.html. No problem. I have a file called index.html. Inside of it is a wall of HTML. I'm going to go ahead and serve that to you. So it's going to serve you HTML, JavaScript, and CSS. That's what's included in all, that's what web pages know how to work with. All right, so an HTTP response that's giving you data will always have that in it. All right, so HTTP is the language that web browsers speak to web servers. All right. All right, so they're speaking HTTP. Now, for us, now English is a huge language, right? Let's see, does anybody in here know how to speak Korean? Okay, good. So let's say we wanted to learn Korean. Is that something we could learn in 5 minutes?
Yep.
Are you good at natural languages? Do you pick them up quick? Or this is just a thing?
No, I was just.
Because it is kind of ironic. I can usually pick up a programming language in an hour or something, operating off of that. You know, all languages have ways of remembering stuff, asking questions, repetition, get those, and then just natural languages I am terrible at. I had like 3 years of Spanish I can barely order at Taco Bell. And I'm using like the menu with the pictures. So, but HTTP, we're going to learn in 5 minutes. HTTP has 4 functions that we care about. Okay, this predates API. So we have a function called get. We have a function called post. We have a function called put. We have a function called delete. All right. Now, get, yeah, this allows us to request a value. So get requests, and that's what it was designed for. There's nothing special about get, post, put, delete. It's not like they're encrypted in different ways. These are, you could think of these like function calls. So get is used when it's making a request to get some information. And what's nice about web browsers is this is our get call right here. So when you put something up into the URL, that HTTP thing that's being formed there is a get. So any endpoint you ever find on any API that uses the get function from HTTP, you can test right from the URL. You don't have to write any program or anything. You can get what we're looking at right here from that. Now, if you want to do a post, so, well, let me just show you gets real quick. I know this might be tiny, but when we kind of went through this after it said, you know, /v2/Pokemon, we have a little question mark and then limit equals 100,000, then an ampersand, offset equals 0. So effectively what we have is at the end of the URL for your name value pairs that are going to get passed along through the GET request, we start off with a little question mark at the end of the URL saying, hey, what's coming next is my name value pairs. And then we have name equals value ampersand. That one was nice. That was a good one. Sharp. Yeah. All of a sudden I cast some accidental spell, but wouldn't be the first time. Oh man, look at it. It's way late. So in any case, but
Is the get the colon //? Like, is that
this whole thing is a get.
just because
If it's in the URL,
nature of it being in the search
yeah,
bar?
yeah. By it being in that search bar, the and you've even seen it. So notice here at the very beginning.
Yeah.
At the very beginning of all your web pages, it's going to say HTTP, or more commonly now HTTPS. What does the S stand for? Secure. So it's encrypting everything using SSL that's going back and forth between your web server and web browser, whatever. So it's secure HTTP, but we don't have to worry about that. It's HTTP. So we can always test GET requests from the URL. That makes it easy. And the way we tack on our name value pairs there is through that little syntax. You know, it's delineated by the ampersand and it's after the question mark thingy. All right. We want to do a post or a put or a delete, and we just are stuck on testing that from the browser. No problem. We could just create a little web form and just set the method for that web form to either post, delete, or put. And then you can send and you can look at different things. All right. But usually, if you were testing an API and you were using different endpoints, anybody know the kind of one of the more popular tools for testing? We probably won't really mess with it in here because we'll do it through code. So you can always do it through code. But there's a popular website, and also it's a local application for people's computers. Called Postman. A website and app, or whatever, that lets you form HTTP calls to test your logic for the call before you insert it into your code. All right. So Postman allows you to formulate your HTTP requests so you know that yeah, this is what I want. This is the guy's giving me back what I'm expecting before you just go and start working within that in your program. I probably would just write the code real quick and just output what he gives you. If you don't like it, try it again. It'll be easier to use than Postman. Postman has 30 different drop downs, most of which you're not going to need. As soon as you get into working with APIs that require like an API key, Postman might come in handy just to make sure you're kind of calling them with the right security protocol and stuff. But even then, just it's so consistent for the syntax for it, you don't even need to. All right. So going back into our code here, this guy right here that we just made this call to, he's a GET request. How do we know? Well, because I had it up in my URL. It's a GET request. So if we go to our code now, and I think I already have that URL in there. Right. Let me just comment out all this stuff up here. I'm leaving the try catch in on purpose because the stuff at the bottom here for the Pokemon thing also requires the try catch. You can always see that in the documentation or just wait for Java to yell at you and then wrap it in the try catch and move on with life. All right, so just to kind of show how we talk to this remote thing now instead of our local file, but still using a scanner. So here's our URL string. I promise you this is the same thing I just had in the browser. I'm going to build something called a URL object out of this using that string. So I'm saying, hey, here's this magical Java URL thing which knows how to do URL stuff. And I'm going to say, this is the URL I care about. All right. Then we're going to build our scanner. And we've built our scanners before, right? Our scanners have been built so far using keyboard, system.in. We've used a file. Now what are we using? We're using the stream associated with that URL. We are opening a stream over the internet, which behind the scenes is going to create this socket connection between us and the web server at pokeapi.co. We're opening that up. That's going to give us an input stream. We are building our scanner using that input stream. So now we can read from that input stream, just like we read from the keyboard, just like we read from the file. I'm going to go through here. I'm going to get my response. We're building up this string. I start with an empty string. I'm just going to keep reading from the scanner as long as there's more stuff there. I'll get my response from it using scanner.nextLine, just like we did when we read in from the user. I'll close my scanner so that the actual output stream gets closed or the input stream gets closed. Probably not the end of the world if you don't. And then I'm going to print out that whole response. So there, that's our whole response for that guy. All right, so now what I'm going to do is I'm going to put up a homework assignment that is going to have you process through this response in a way that has you use our JSON parser.java, utilizing the things we learned about today on how to use it. And I'll have you do something that is, reasonable to do with this code. Let me just look at the JSON a little bit more closely. It looks like it's well-formed JSON here. It closes with that. It looks like we have an array in here. This really looks like it's formatted extremely close to how our cruise ship stuff was formatted. All right, so I'll come up with a good little exercise to do over the weekend with this. I'll try to have it up by like noon today, if you'll give me a little bit of time. All right, questions, comments, concerns, bribes. Get put post slide. Oh, we will. Yeah, but right now for this homework, you're only going to need to get. Yeah.
Can you also post the code? Because I don't know if we
I'll
ended up getting.
I'll be giving you the code with the assignment.
Okay, sweet.
So it'll be your starting point for the assignment, everything we went through today.
Okay, thank you.
Yep. All right. I will see everybody later. Or see you Tuesday, whatever. All right, front row at chapel. Anybody who's interested.